In this video, let's look at some basic decision structures in Python. Decision structures, as the name implies, allow you to code decisions, or allow your code to make decisions based on the values and conditions of variables and objects. So, one of the simplest decision structures, so let me make sure, okay, I'm calling the right function. It's just a simple if and else. If, and you test for a condition, and then if that condition is not true, if it's false, then else would happen. Or you can have elif. You can have if, and then elif, and then else. Or you can have a bunch of ifs. We'll look at different combinations of this syntactically and how it works. But in the first example, in Python you don't have to put these in parentheses. In some languages you do, but it won't hurt if you do. So I have a variable, the name. Its value is invader Zem, okay? I'm testing for a condition with my if. In the parentheses, if the name evaluates to be, if it's invader Zem, then we'll say good morning, sir. Okay, but if it's not, if it's someone else, we'll say intruder alert. So we'll run this the first time. I'm gonna hit F5. And it just says good morning, sir. I'm just gonna add some lines here so it differentiates, right? So because it's invader Zem, it says good morning, sir. But if it's not invader Zem, what if it's, what if it's me? Then what happens? Hit F5 and run it again. Intruder alert, okay? Oh, let me add some lines here too, okay? So again, if it's invader Zem, and we run it, good morning, sir. All right, so that means this portion here, the test portion, the condition, if it's true, the name does evaluate to be is equal to invader Zem, so it displays good morning, sir. But if it's false, and we were to run this again at F5, it says intruder alert. So very simple, basic decision structure in Python. Let's look at another example down here, and let's run function 2. Okay. So here we have the score. It's 42. If the score evaluates to be 42, what? Print the meaning of life. Douglas Adams, if you like Hitchhiker's Guide to the Galaxy and that series of books. Very funny. Otherwise, if it's false, if it's not 42, void of any meaning or purpose. And again, let's just see how that works. In this case, the score is 42, so this condition portion is true for the if, and so the meaning of life. And again, just to make this more apparent, let me add some lines here. Okay. Now what if it's false? What if instead I'm 53? Or whatever. What if that was, what happens then? Well, that condition is no longer true. So void of any meaning or purpose. But if it's 42, and I run it again, the meaning of life, according to Douglas Adams and the Hitchhiker's Guide to the Galaxy. Let's take a look at another example. We're going to clear the console here. And all right, so decision structure is 3. We're going to run this function. And look, test scores. We have an array, a list here, a collection of test scores. And they're all different values. For Z in test scores, which is going to, as our repetition structure, which we talked about in the last video, for the number of elements in test scores, we'll go through it. And we're just going to use if and elif and else. So if is the first tester condition. Elif, else if, short for else if, elif, all the conditions that come after it, and else is the final. If none of these conditions are met, then this last else would be executed, okay? The square is invalid. And let's add an invalid square there. There, we'll add something there, okay? And the square is invalid, all right? Otherwise, the first test, is it greater than 0 and less than 60? Well, they got an F, all right? And we're using the logical AND operator. And a logical AND operator means that both sides have to be true. So if I say AND, so in other words, we start out with is z greater than or equal to 0 and is z less than 60. Both sides have to be true. It has to be greater than or equal to 0. No negative values here. But it also has to be less than 60. Because, at 60 we assume, well, it depends on the grading scale, would be a D. Low, but a passing grade. Okay. So AND means both sides have to be true. This side and this side have to be true if you use AND. Whereas if you use OR, only one side has to be true. The other side can be false. So the logical operator we want in this instance is AND. And we may go over this in more detail in another video, but just for now, I guess it's a good time to bring this up. For now, logical comparison operators, and OR, okay? I'll add some comments here. And both sides have to be true, okay? And or only one side has to be, and you can nest these and link them together and come up with all sorts of complex logic. But in this case, all these ands, it just means both sides need to be true, right? So this is how we would code and specify a range in our decision structure. So if this isn't the case, and this isn't the case, we drop down here. Well, is it greater than or equal to 70 and less than 80? Then they got a C. Is it greater than or equal to 80 and less than 90? Then they got a B. Remember, both sides have to be true. Is it greater than or equal to 90 and less than or equal to 100? Then they got an A. In other words, there's no extra credit. There's no values over 100 tolerated in this instance. So, and then we would say this score is invalid. So that should be produced, or this should be caught in our remaining else here. So if, elif, and else, and OR. Okay, very important concepts in Python or any programming language to use with decision structures. Okay. So let me hit F5 and run this. Okay, so again, DB, AF, ADB, those were all the valid ranges. But then we hit this 444 that I added up here. That was invalid. And so it got caught by this else. This is sort of our catch-all. This else, if, and that's the first condition. And then if not if, all the elif. And then if not that, then we catch it with the else. You could also have simple if and else, as we did above. You could just have a collection of if statements, okay? Which sort of emulates a switch statement. There is no switch statement in Python, just like there's no do while, there's a repetition structure. But again, with a short abbreviated single line statement series of ifs, you can basically emulate a switch statement as you could use in PowerShell, C++, Java, and Python. Okay, let's take a look at the next function. And we'll go to function 4 now. Okay, just an example of using it on the same line. So look, we could, in a single condition here, we have two integer variables. If square 1 is greater than square 2, print the square is greater. And I don't have to use the parentheses in the condition portion. I just do that out of habit because you do that in like C++ and Java and PowerShell. For me, it makes it easier to read the code, easier to follow the code, less likely to make mistakes, but it's optional. Just like adding semicolons is optional, okay? And then if the square 1 is greater than square 2, print square 1 is greater than square 2. print A if score 1 is greater than score 2, else print B. Let's just see how that looks, or how that works. Hit F5. B, okay? Actually, let me clear this and run it again so you can see better. Alright, so why? If print A, if score 1 is greater than score 2, else print B. Well, it's not going to print, in this case, A. Why? Because score 1 is less than score 2, okay? And let me... Now, this up here, is score 1 greater than score 2? No. So this never happens, right? This never happened at all. This did happen, in this case, you know, in a compound statement on a single line, print A if score 1 is greater than score 2, else print B. So we have an if and an else. We had no else here to catch it. And so this line did not execute. Now, if we were to change the values and I were to say score 2, if we were to invert this on each side of the greater than symbol and I ran it, see, now it says score 1 is greater than score 2 because I inverted it. I'm going to change that back as it was. And again, to make it more readable, I will add some lines here with my escape sequence. Okay, and then let's add an else. Else and I have my colon there. Let me add some lines, and doesn't matter, but I'll just try to keep it consistent. Okay, keep it consistent there. So clear the console, run it again. Now, because I've added an else, score 1 is not greater than score. Oh, I didn't put 2, did I? I left 2 out there. Alright, score 1 is not greater than score 2. And I didn't mean to put that 2 there either. I'm doing all kind of bad stuff here. Okay. But it, you know, still, score 1 is greater than score 2. No, it's not. So else print B. So here's the if and the else all on the same line. And here's if else. And you've seen how if I just have an if and no else, and the condition isn't met, that code just never happens. Okay. Let's go take a look at another example of a decision structure. We'll run function 5. And let's see what happens in function 5. Function 5. Okay. So or versus and again, all right? Remember with the logical and operator, both sides have to be true. So in this example, in this code, right, score 1 is 42. Score 1 is the value of 42. Is it greater than 10 and is it less than 42? No, it's not, right? It is 42. Score 1 is 42. It's not less than 42. And it's greater than 10? Yes. Yes, that condition's true. But is it less than 42? No, it is 42. So remember that logical and says this side and this side have to be true. Otherwise, it's false. And that condition, the code underneath that condition won't happen. So because it's and not or, that line won't print. Why? Because score 1 is 42. And because it is 42, it's not less than 42. Yes, it's greater than 10, but it's not less than 42. It's equal. And so because one of those is false and one of those is true, that condition is false. Because and says both sides have to be true. Now, on the other hand, in this example, is score 1 greater than 10 or score 1 less than 42? It will print the line beneath it. It will execute the code. Why? Because logical or is different from logical and. Whereas and says both sides have to be true. Logical OR says only one side has to be true. This side or this side. This could be true, this could be false, or this could be true and this could be false. But only one has to be true. And so yes, it is greater than 10. Square 1 is 42. It is greater than 10, but it's not less than 42 because it is 42. So in this case, the code will execute that trigger. It'll be triggered. That condition has been met because it's logical OR. But up here, because it's logical AND, this code will not execute because both sides have to be true, and that's not the case. One of them is false. Are we thoroughly confused yet? Let's run the codes and see what happens. All right, so it only ran this code, target condition be triggered. Why? Because OR only demands that one side be true, not both. All right, the only way for this code to run here, we would have to modify this, say less than or equal to. And because square 1 is equal to 42, then both sides would be true. Yes, it's greater than 10, and it's also less than or equal to 42. And if we did that, I'm gonna add a line here and a line here. Again, just to make it easier to see. So it's separated on the console. But hit F5, run it. Target condition A triggered, target condition B triggered. I can't speak English. But yeah, why? Because again, just note the difference between AND and between OR. You know, OR says only one side has to be true, AND says both sides have to be true. Let's take a look at the next function here. Okay, in this last function, we're going to combine all the stuff we talked about so far in previous videos, stuff we know. So well, we got a repetition structure, a while true loop here. We've got a sentinel value in the condition portion. We're using input to take input as a string. We're testing for that condition in a decision structure. We're going to use isDigit to determine, is it numerical input? You know, if we ask the end user for some numerical input and they type in apple or lasagna, we don't want that. We can't do anything with that. We can't calculate or do math with that or use that in a comparison. So we need to validate and mask that input and make sure they give us good input and not garbage. Garbage in, garbage out. You've heard that before probably, right? Gigo, garbage in, garbage out. Well, if you mask your input and you test it and parse it and check and make sure that the end user is giving you the right kind of input, there's less of a chance that your program will crash. Oh, they'll still find plenty of ways to destroy your application and crash it by doing things that they shouldn't do with it. But you at least try to make it more user-friendly by masking and validating the input and making sure it's of the right type, the right data type. Okay, so we want to check. We're going to use isDigit. We talked about that in the previous video. And is it a digit? Is it numerical? Fine. If not, we're going to come down here and say, hey, that was not a number. But we're going to stay on the while true loop unless they give us Q to quit. Okay. If it is a digit, then we will convert the string, right? We'll typecast it or cast it to an integer. And store that in score. We'll say your grade is, and we specify this to print. So when we call print again, that way it won't print it on a separate line. We want all this to be concatenated onto the same line. So that's why we're saying end equals and then 2 single quotes. That way it tells print not to add a new line the next time we call print. And then this is sort of approximates a switch statement. We don't have a switch statement in Python, but this is almost as compact and as concise as a switch statement. And actually, using if and elif, it does a lot more. It's capable of a lot more logic than a simple switch statement. You couldn't have compound conditions in a switch statement in languages like C++ and Java. Switch statements have to be very simple. But being a condensed single line series of if and elifs here in Python, my goodness, we can do all kinds of multiple expression comparisons, and it can be all sorts of different data types. The possibilities are actually a lot more. It's a lot more flexible, a lot more versatile doing it this way, and it really doesn't take up that much more room than a simple basic switch statement, does it? So there's really no need for a switch statement in Python, just like there's no need for a do while loop, because using a while true loop and then testing for a sentinel value achieves the same result in Python as using that structure, that feature in other languages. But we're going to say, look, if it's less than 65, it's an F. Greater than equal to 65 and less than 70, it's a D. Greater than equal to 70, less than 80, a C. 80 to 90, B. 90, 99, an A. If it is a perfect 100, we'll say, hey, perfect A plus, 100%. And if they did extra credit, this time we'll allow something greater than 100 for extra credit maybe. So say they got 102 or 103 for some extra credit assignment they turned in or did A++. Awesome. That's what we'll display. And then this will just keep running infinitely until we give it the sentinel value of Q to quit up here. All right? So again, so you can see all the code at once. Here's the function, here's the method. Now let's run it and test it out and see if it does what we want. Gonna clear the console, hit F5. Let's run this puppy. What was your score? Well, let's check the sentinel value. Does it quit? It sure does, it quits. Okay, clear the console, let's run it again. What if I give it some weird value instead of an integer? What if I type in apple? Maybe I'm hungry. That was not a number. So isDigit tested it, right? It parsed it, said, hey, this is non-numerical data in the string. And so our else was executed. That was not a number. We're validating the input, right? We're going through the input, we're testing it to make sure that it's valid data and not some crazy gobbledygook the end user typed in that will just destroy our application, our program. Okay, what was your score? All right, let's type in an actual number this time. But what if I did this? That was not a number. We don't want a negative value. What if I did this? Okay, converting the string data, we're tolerating values over 100. I don't know how you get a 444. That's a lot of extra credit. But the point is, because of the way we coded it, in this example, unlike the last one, we're allowing a value to be over 100. We're tolerating that value, so 444. Now let's look at a valid range of grades. All right, so 60, I got an F. 65, bare minimum, I got a D. 70, I got a C. 75, I get a C. 80, bare minimum, B. 89, all the way to the top is still a B. 90, well, it's the bare minimum to get an A, but it's still an A, right? A 95 is an A. Let's get a perfect 100. All right, perfect A plus, 100%, woo! And let's say we got 102 for extra credit. Grade is A++, awesome. And now I want to quit, there. And so that's just an example using all the things that we've talked about and covered so far. And you will find plenty of projects below. In the description tag, there's links to projects that I've already uploaded, and the code's on GitHub. So you can grab the code, load it up in Visual Studio Code in your Python and go through it if you want. Type it in, modify it, warp it, twist it, change it. That's the way to learn, especially if you're a tactile or a kinesthetic learner. It's not enough to just watch it or listen, but you gotta do it. You gotta do some coding, and then it will stick in your mind. But you can do that and apply all you know and go through some of those projects, such as the Guess a Number game. Well, we haven't gone over random yet, but we will. Such as the Scramble Word game, tic-tac-toe, things like that. There are plenty of projects that you can work on to practice the concepts that we've talked about and gone over so far. But these are basic decision structures in Python. Thank you for watching this video. And if you like what you see, please click on subscribe and hit the notification bell. And then when I make another video, you'll be notified. Thank you for watching. Bye-bye.